Okay. Well, that was annoying. I'm sorry. Unfortunately, if it happens, it somehow accidentally the recording stopped. If that happens, I'm just gonna have a bunch of videos that are just kind of piecemealed together, and you're gonna have to start a new video. I'm sorry, students. Sub, very kind sub. Be nice to the sub. They don't have to um help out, and they're having to go out of their way just because I'm having a baby. So thank you, sub, whoever you are today. Um, anyways, what we were talking about. We were talking about the AP questions are um, usually not going to use, not going to have equal subintervals. Um, again, I don't know what I did last time to turn this off. I'm going to try not to do it again. I have a touch screen, so I think it was my hand. So again, on the AP, you'll see, like I said before, on the AP, instead of having like the X, the X values be like somewhat evenly spaced like that, um, on the AP, they'd give you more like, oh, look, these are close together, and then these are farther, and then these are like medium, and then like these are like close again or something. And so in this case, if they give you subintervals that are not evenly spaced, then obviously this whole b minus a over n thing is not going to work. Actually, I did 1, 2, 3. Oh, I did 4 subintervals here, right? Because if you do b minus a, which is that whole thing divided by 4, here, great, you're going to get that length. But here, each time is different. So here you might have, I don't know, wee or something. Here, if you have intervals like this, let's say it goes down to here, I don't know. Then you're going to have like one trapezoid like this, and then you're going to have a trapezoid that's like real wide like that. And then you're going to have another one that's maybe also pretty wide, and then this one that's short again, right? So when you're doing these that have unequal subintervals, you would still use this part because you're still going to average like the two sides, but you cannot use this whole b minus a over n formula thing. You can't do it because you're not multiplying it by whatever this is each time. If they're equal, great, you can multiply it by that because this width is the same as this width is the same as this width. Oh, just kidding. Whatever. I did 3 versus I did 4 here, so that's also different. Obviously, that would change the n value, but hopefully you get the idea. That's really important. That's why I don't really love the book in this section, or at least don't love the AP. I don't know. There's not like perfect overlap here. So then the next thing we're going to do, so in general, all you need to know for the AP and really even for the quiz or whatever it is that's coming up that's going to cover this section is that you just pretty much need to basically know how to find the area of each trapezoid. You apply this basic rule, and if you can't use if there's no equal subintervals and you can't use the b minus a over n, right, then it should be obvious what the widths are, right? They would have to give you the numbers. So they would give you, I don't know, let's say this is like 3, 5, 9, I don't know, 12, 13, right? Well, then the widths here, right? Then the widths you would just have to calculate individually. 3 minus 5 is 2, right? No, 3 minus 5. 5 minus 3 is 2, right? 5 minus 3 equals 2. That's that width. 9 minus 5 equals 4. Okay, 12 minus 9 is 3. 13 minus 12 is 1. So your widths here would be see if I can do this. Hello. Okay, back to yellow. So your widths would be 2, 4, 3, and 1, right? And so you would plug those in up here in your formula. So you would still take, like in these cases, and we're going to go over these. I have, I think, 2 examples on the worksheet. That's why it's that AP worksheet that hopefully you were given or will be given today. And we're going to go over is really important because you're going to be given this information mostly in table form, and then you're going to have to average the 2 like heights, and then the average of those 2 heights times the width will give you the area of that trapezoid, and then the average of that height and this height times that width would give you this trapezoid's area, and then the average of this height and this height times this width would give you the area of this trapezoid, and so on. So you can do it manually, just literally knowing basically how to take the area of a trapezoid for each of these, sum up those areas, and bada bing, bada boom. Okay, but the book focuses on something that I think the formula itself is what they're calling the trapezoidal rule versus just saying a trapezoidal sum. The trapezoidal rule itself is at the top in a box on the top of 348. There is a derivation on the bottom of page 347 in your textbook. I don't really know if it's worth. I think I'm going to go over this very quickly. When I first started teaching this, I taught this fairly strictly. It was like, yeah, you need to memorize this formula and all this stuff. But honestly, memorizing the formula tends to confuse people and makes them get the AP questions that do not have equal subintervals wrong. Once they've learned the formula, they think in their mind every time they hear trapezoidal sum, they think, oh, gotta use the formula, and that's not right. For the AP, I don't know if you'll ever use the formula. I don't know. It's kind of like the limit-based definition of a derivative, where like it's like a kind of a classic part of the curriculum, kind of, but it's just the AP doesn't tend to use it, but I can't guarantee you like they wouldn't throw it on like a multiple choice question or something. It's possible. So anyways, so if you have your book, get your book out to page 347. I'm actually kind of afraid to erase this. I think I'm going to do one of those like things where you kind of just let's see, I'll keep it big. I'm just going to kind of like push it. Yeah. I don't think I'm going to erase everything. At least this way maybe I can save this somehow. I don't know. We'll see. So please look at the bottom of 347 if you can. I'm probably going to write out most of this, but I'm going to mostly kind of talk as if you're kind of already looking at the textbook. So you can kind of see the things that I've already drawn kind of already look like what's going on page 347. You see the little like trapezoidal regions below the curve in figure 5.42, and then 5.43 you see that little they did the little formula. They chose to do the one from x sub 0 to x sub 1. Same thing. Again, the book goes with the b minus a over n without any caveat because they just assume, oh yeah, there's always going to be equal subintervals. In the book's world there is, but and so if you think about it, if you were to write out a bunch of areas of trapezoids, so I'm looking, and I think I'm gonna try to write this down, but it's a lot of writing for not that much benefit, to be honest. I'm looking now in the middle of the page where it says this implies that the sum of the areas of the n trapezoids is, and then below that's area equals. All right, so a few lines below where it has the last interval-y thingy. So essentially, if you are adding, so the formula that I wrote down where you average the 2 function values and multiply by the b minus a over n, again, that's only assuming equal subintervals. If you add that up, right, that's just for one trapezoid. So you add that up for all the areas of all the however many trapezoids there are. In fact, I think all the ones that you're given on your homework, even the book work, I think n is always 4, meaning 4 trapezoids, which means you really can do your homework, even the book work, without doing the trapezoidal rule. If you want to be an overachiever or you want to just go for it and try to use the trapezoidal rule, that's fine. The book questions are going to have equal subintervals, so technically it's a little bit more efficient to use the trapezoidal rule because it just like avoids like extra calculations. It just kind of like, yeah, anyways, you'll see. Also, side note, I'm noticing already on the homework there's like something that says, like for number 1, use the trapezoidal rule and Simpson's rule to approximate the value of the definite interval, blah, blah, blah. No, we're not doing Simpson's rule. I don't remember Simpson's rule. You don't need to know Simpson's rule. Anytime it says Simpson's rule, ignore, ignore, ignore. Just do trapezoidal stuff. Okay. Okay. So, all right. So the area, right? So again, we're saying the area like this. A to B. Hello, where'd my? All right, come on. There we go. Integral A to B. F of x dx. All right, approximately equals, and this is for area of trapezoids, area of n trapezoids with equal spacing. So this would be b minus a over n, right? That's the width. B minus a over n, and so the width times all the heights, right? So since every single trapezoidal area would be the width times the height, the width times the height, the width times the height, right? The width times the height plus the width times the next height plus the next width times the next height plus the next width times the next height. So, but all of them, if you have equal subintervals, then that's going, again, so this is only, right, again, no, we're not done with this formula, by the way. We're not done. We got other stuff to write. Again, only for equal subintervals. Okay. So you'd have the width times the height for every single one. So you can factor out the width if all the widths are the same, right? If the subintervals are the same. Subinterval, right? So this means width, like the x2 minus x1 type things. Okay, so you could factor that out. And then you could add up all the heights, right? So at that point, then you would have the average of the height between the first and the second x value, right? And then you'd have the plus the average of the, right? Because this would be like the average of the 2 heights, which would be like the new height of that like modified trapezoidy thing I showed you. Plus, and then you're going to have a whole bunch of stuff to insert in between these, depending on how many trapezoids you have. And then you'd have the very last one, right? They're all the same. You're just averaging. So if there's n trapezoids, that means the last one would be averaging the n minus first height and f of x sub n. Okay, oh my gosh, I keep like staring at the recording clock. My worst nightmare would be to like have to redo all this. Okay, so this is the very last one because x sub n, that's the height of the last one, right? Because we're like doing something like this, and then we're like whatever, right? So if that's like the last one, then you have the average of this thing and that thing, and then like boom, you stop. That's at your B value and that's at your A value, right? If that's like the thing. Over to, right. So this is essentially that formula I had where this is the, like the average height, right? Average height times width, right? So this is the width right? And then each of these is an average height, right? Essentially, it's like, since another way you can think of it is, since this is a straight line here, if you take this average height, like the average between that top y value and that bottom y value, it's almost like you could think of them as rectangles averaged. Now, don't mistake those for, hopefully we already talked about this, midpoint Riemann sums. They would only be, trapezoidal sums would only be equal to midpoint Riemann sums if literally the function behind here was perfectly linear and not curved. It's hard to see, but if this is curved, then the actual midpoint here is actually, like in this case, a little bit higher than the average of those two. Anyways, so it's not the same thing as a midpoint Riemann sum. Oh, height. Okay, well, so what the trapezoidal rule does, first of all, it factors out the width, so that's a little bit more efficient. But if you notice, and I'm not going to write out all this because it's too much to write out. Actually, well, the book writes it out because reasons. Write out, whatever. I'll write out what they write out, I guess. But whatever. If you're running out of time, I guess you don't have to see this part, but what we're going to do after this is going to be really important. So the next thing, well, let me just move this down because I don't want to erase anything. Well, let's see. I want to move this down though. Let's see if I can get this and move it. Oop, nope. How do I do that? Nope, don't want that. Like a lasso thingy. Is that gonna work? Not really. Nope, didn't work. All right. Whatever. Come on, move. Nope, I don't want you anymore. Move. Nope. Oh, come on. No. How do I move the whole thing? So annoying. Just when I thought I was mastering this. I want to move this whole thing. How do I move it? Do I? No, I don't want to draw with my two fingers. Silly. I used to be able to move this thing. Do I need to like D-tap on this maybe? No, I can't D-tap on this. How do I move this? Oh goodness. Let's see. Yeah, get back into this mode and there we go. Okay. I don't know how I did it before. There we go. I'll just make that all small so you can still reference it. Okay. Whew. So if you were to write out all this, I'm going to try to hurry up. If you were to write out all this, you'd still have the b minus a over n. First of all, notice you would actually have, look, see there's 2's because you're averaging everything. So this 2, I'm going to go ahead and factor out the 1/2 essentially, right? And put that up here, put it in the 2, right? So this is factoring out, well, this thing is going to get in the way, isn't it? Let's see, factor out the 1/2. Okay, so that 2 goes there. So that goes away. So then we just have f of x sub 0 plus f of x sub 1. Now, if you imagine what lied in these terms in the middle, the next one would be f of x sub 1 plus f of x sub 2. So when you factor out the 1/2, you would have an f of x sub 1 plus f of x sub 2. Now, the reason for that, right, is because you're averaging. So like for here, you're averaging that height and that height for the first sum, but then for the next trapezoid, you're averaging this one again as the left height averaged with the right one there, right? And then when you go to the third one, then you're averaging this same one you just did plus that next one. This would be kind of convenient for teaching, just having a marker that instantly disappears. Anyway, so that's why you're going to see there's a pattern where these are going to keep being reused, right? Except at the end. Notice that's very important. So like this first one, you use it only once to average with the second height, but then you move on to this second trapezoid and it doesn't get reused. So only the first one and the very last one don't get reused. So you have f of x sub 0 plus f of x sub 1 plus f of x sub 1 again. So notice these are the same. And then you're going to actually end up with 2 f of x sub 2's plus dot dot dot. And then you're going to have, see, now this is working. I don't know. And at the end, right, you're going to have 2 whatever plus f of x sub n minus 1. You're going to have 2 of those, f of x sub n minus 1 plus f of x sub n. And there's only going to be one of those, right? So there's only one of these, right? Only one. And then back here, same thing here. There's only one at that endpoint, only one, right? But for all the other ones, you're going to have 2 of them. They occur twice because they occur as like the right bound of the trapezoid to the left and the left bound of the trapezoid to the right, right? So anything in the middle is going to be used twice as the right and then also the left bound. Okay, anyways, this is not super important. You don't have to use it. I'm mostly kind of just like, for your own education. I would kind of feel like I don't know, subpar calculus teacher to not at least show you how this formula works. So in all, here's technically the formula. And again, you technically never have to memorize nor use this formula in my class. So probably like, all but 1 or 2 of you are like, stop wasting my time. But anyways, this is what it is. So you have the b minus a over 2n. Again, remember it's 2n because we factored out the 1/2 thing. And then you have f of x sub 0, which occurs by itself. So that's just a 1 coefficient there. But then from then on, it's 2 times, right? Because there's 2 of those. F of x sub 1 plus 2 times f of f of, let's not do that. 2 times f of x sub 2 plus dot 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 plus 2 times f of x sub n minus 1 plus just 1, right? At the end, it's times 1. F of x, right? Because at the very end here is only times 1. F of x sub n, close that, do that. So this is the formula. So this is the trapezoidal. Let's see, look at that. Ooh, I look like, you guys see those YouTube videos where they do like the drawings and then at the end they like show you the whole thing and it's like this amazing thing? Well, this is like partly like cool, but also partly like, oh, subpar handwriting calculus that some people think is boring. I guess a little bit depressing than that. But anyways, trapezoidal rule. So this is the trapezoidal rule formula. Okay, but, all right, so that's this thing right here. That's what's on the top of 348, but you never have to use it, and it's only applicable for equal subintervals. So you never required to use it. No, this one. To use it, and never required to use it, and and only applies to only applies when you have equal subintervals it's kind of a cool formula just because you see how, formulas are made from like starting with the idea of a trapezoid and then kind of just like factoring stuff out, noticing patterns. I don't know. So I think it's kind of cool to see, but so you're never required to use it. And so instead of that, you can always just sum up areas of the trapezoids by hand. So you can sum up areas of individual trapezoids by hand, right? Like with 1 times the average of over there of, right, like with 1 times the average of heights 1 plus with 2 times the average of heights 2, right, plus etc., right? You can just sum them up by hand. Okay. The next thing I want to do is now go over the workbook answers. I guess I could make that a new video. I don't know if it would be useful to keep on making super long videos and you can just cut them off whenever, or try to chop them up. So I think I'll cut off this video and I think I'm just going to start a new video that says going over the explanations of the homework, of the AP worksheet homework. Okay, see you in like 10 seconds.